All right, domain, set of all x values. Another word you've seen before is range. And what is range? Set of all, good job, set of all y values. All right, domain is the one we'll be focusing on today. Find the domain. All right, first type of function I'm going to focus on is parabolas. All right, number one, f of x equals x squared minus 3x plus 2.
Do we have to graph that?
Good question, and that's what I was hoping to address in this problem. He said, do we have to graph this? You might have to or might want to initially, but I'm hoping eventually you will not have to. At least know what the shape is. What is the shape of a parabola? A U shape. Does everybody agree with that? Now, does it matter where I draw my U shape? Right, left, opening up or down? What is my domain going to be?
All rails.
All rails. Can you guys see that?
Yeah.
Does it matter if it's opening up? Down? How wide? Thin? No. Did they do this during first period?
No.
This first one? Okay. All right. Listening. Okay. Domain. Domain is what? You guys said it. All reals, all x values. Do you guys remember this shorthand?
Yeah.
Okay. I will tell you this. You should know this. You should know that this means all reals, but we're going to write it in interval notation. So how does all reals look in interval notation? Negative infinity to infinity is the answer. Now, that is true for all parabolas that open up, down. It doesn't matter how wide, thin, where the vertex is. Do we all agree? All right. Now, it does change if the parabola has restrictions. For example, something like this. X squared minus 3x plus 2. All right. Sorry, there's more. Comma. X cannot equal 5. All right, so what's the difference between number 2 and number 1? There's a restriction. Does everybody see that? Okay, so it doesn't matter how wide or thin or up or down the parabola is going. It doesn't. I'll show you why. Which direction is this parabola opening? Up. We should know that, but it doesn't matter whether it's opening up or down. 1, 2, 3, 4, 5. What it means at 5 is that you have an open circle. Why? Because x cannot equal 5. Does that make sense? Do you guys remember this? If x cannot equal 5, that means your graph exists everywhere except at the point 5. Bless you. Do we know what the y value is? Not, I mean, it's not necessary, but if we needed it, could we find it? Yeah, what would I do with the 5? Plug it in. Is it necessary? No, because domain is a set of all x values. Our restriction is x cannot equal 5. So, does anybody know how to write that in interval notation?
So would it be parentheses 5? Parentheses
And then the 5 in a bracket?
No.
No. And then what comes after? Union? 5 to infinity. All right, now it took us a while to get there, so I'm just going to review really quick. How can you, if you're not sure how we got this, for you visual people, just do this. What does it mean to equal everything except negative 5? Do you agree everything is shaded on your number line except the negative 5? Everything except the negative 5. Everything to the left, everything to the right. And how many of you, when you see it this way, this makes more sense? Negative infinity to 5, parentheses, because it's an open circle, 5 to infinity. Make sense? Yes or no? All right, any questions on parabolas? All right, I'm going to move on to fractions. Part 2, fractions. All right. Number 1, f of x equals x plus 5 over x plus 3. Have you guys seen these before? I know you've at least seen them in this class when we did the solving back in Unit 2, beginning of the year. We talked about restrictions. Remember, we talked about restrictions. Does anybody remember what they were or where we looked at for the restrictions? For denominator. Because the denominator what? Cannot equal 0. I'm going to put that in bubbles. So whenever you're dealing with the domain of a fraction, is this what you're looking at? The denominator cannot equal 0. Yeah. Do we care about the numerator? No, because can the numerator equal 0? Yes. All right, so x plus 3 cannot equal 0. What can x not equal? Negative 3. Now, if you just write that, is that okay? No interval notation. Remember what I said earlier. If you can't picture it, do this. Open circle. Everything is shaded except for the negative 3. What does my interval notation look like? Negative infinity to negative 3. And what do I put on the negative 3? It's an open parentheses because it cannot equal negative 3. Otherwise, I wouldn't need this union piece. Union what? Good job. So this is saying everything except for negative 3. Got it? All right. Number 2. F of x equals 3x minus 2 over x squared plus 4x. So I just want to show you special cases that you're going to see. Do I care about the numerator? No. I take the denominator, and what's my equation going to look like? X squared plus 4x what? Equals 0 or cannot equal 0? All right. Now, kids often struggle like, oh, I don't know how to factor this. We always forget what's the basic factoring? GCF. What is the GCF? X, that leaves me with x plus what? 4 equals 0. Set them both equal to 0 and solve. How many restrictions do you have on this one? 2, and that is a possibility. All right. What are my 2 restrictions? X cannot equal 0, and or what? Okay. Again, if you struggle with this, I suggest you do this. Even if you think you have a handle on it, just do it just in case for now. Negative 4, 0, do you guys agree that's in the proper order? Open or closed on the negative 4 and the 0? Open because it cannot equal those numbers and everything else is shaded. Make sense? Is that a yes? All right, interval notation. How do we write this? Negative? Okay, and parentheses or brackets on the negative 4. Okay, and then union. Negative 4 to 0, parentheses on both. And then union 0 to infinity. All right, questions on this one? Yes? You use brackets if this circle was closed in, if it was equal to. And we know it's not equal to because that's what we're making our restriction. It cannot equal 0. These are the numbers it cannot equal. So if it cannot equal them, you're using parentheses. Brackets means it includes those numbers it can equal, and that's not our case for this problem. Good question. You're welcome. Number 3. Here's another one that kids mess up often, especially on the test. 7x over x squared plus 25. F of x equals 7x over x squared plus 25. All right, I take the denominator, and it cannot equal what? Do I care about the numerator? All right, does this factor? Can I factor x squared plus 25?
Yes. No.
I see some nodding yeses. I heard some yeses. I hear some no's.
No.
Okay, those of you saying yes, tell me how to factor. Difference of two squares. Anybody stopping me? Okay, good job. What is it called? Difference of two squares, and what does difference mean? Subtraction, difference, takeaway. Is this a sum or a difference? Okay, so is that correct? Just kidding. All right, just checking if we knew what we're doing. Anyone else? A factored up form? Okay, now here's another way to think of it. If I cannot factor it, I can get x squared by itself, yes or no? And then what would I do to both sides? And can I take the square root of a negative without using imaginary numbers? No, we don't use imaginary numbers when we're looking at domain. So, what does that mean about restrictions? Are there any restrictions? No restrictions. What does that mean about my... Okay, hold on before you answer my next question. Any questions on this no restrictions? This is no solution. Does everyone agree I cannot take the square root of a negative number? So that means, is there any number, any real number, that would make this denominator 0? No. 5 squared plus 25 is not 0. What about negative 5 squared? It's still not, because negative 5 squared is still 25. Is there any real number that would make this denominator 0? So that means there's no restriction. No restriction means what about my domain? All reals, good job. And we don't write it like this anymore. We write it like what? Negative infinity to infinity. Questions? Okay, do you see why people mess it up? Yes? They factor, they give me different answers, they say positive 5, negative 5, or a variety of different things. Be careful and put cell phones away, please. All right, part 3, radicals. Number 1, f of x equals the square root of 7 minus x. Okay, who remembers how to do this from Math 3? Something with the inside. Okay, let me back up. This one denominator could not equal 0. Do you agree? Because you can't have a fraction over 0. This one, can the inside equal 0? Yeah, because the square root of 0 is 0. Okay, so there's no restriction with the 0, but there is a restriction. You cannot take the square root of a negative. So the inside, how would I put that mathematically? The inside using inequalities. The inside must be what? Greater than or equal to. Good job. Because the square root of 0 is 0. All right, so whenever you're dealing with the square root, is that true only for square roots? Cube roots? Even roots. Good job. I'll put a little note there. Even numbers. Now, when there's no number there, is it automatically a 2, a square root? Okay, Austin, can you tell us why you said even? Like what is it?
If it was like negative 3 to the 4th power, you're going to come out with a negative, or negative 3 to the 6th, you're going to come out with a negative. If it was negative 3 to like the 3rd or 5th or 7th, it would be positive.
Flipped around?
Yeah, my bad.
It's okay. All right, so do you guys see? So can I take the square root of a negative? Can I take the cube root of a negative? Yes. So is this restriction true for cube roots?
No.
No. For square roots and any other even roots. So 4th root, 6th root, and so forth. Make sense?
I said that right.
Okay.
I said when it's an odd number, you'll come out with a...
It's okay. It's okay. All right. 7 minus x is greater than or equal to 0. Solve that. Subtract, divide. Don't forget what you do when you divide by a negative. All right, negative x is greater than or equal to negative 7. Did you guys divide by a negative 1? Or you moved it the other way. Either way, you're going to get x is greater than equal to or less than equal to. X is less than or equal to negative 7 or positive 7? All right, now, how do I write this in interval notation? Sketch it if you're not sure. Open or closed on the 7? Shaded to the right or to the left? to the left. So do I start at 7 or at negative infinity? And I end at, now parentheses always on infinity. In this particular problem, Lauren, can you tell us, since it's closed, what would I put? Parentheses or bracket? Bracket. Questions? All right, so that means only numbers less than 7, including 7, would work. Let's check it. What's 7 minus 7? And square root of 0 is? And does that work? Which is why there's a bracket. What about a number to the right? Let's pick 8. What's 7 minus 8? And can I take the square root of a negative 1 with real numbers? No. So do you see why the solution's everything that's smaller than 7, including 7?
Yes.
Yes? Even negative numbers. Let's try negative 2. What's 7 minus negative 2? Can you guys do that in your head? 7 minus negative 2 is what? 9. And can you take the square root of a positive number? Yes. There was a hand up. Bless you. Yes.
Thank you. How do you know it's a closed circle?
Right here. And that's not a dumb question. Equal to. If you have an equal bar, her question is, how do you know when it's open or closed? We had it in our notes on whenever day that was, Friday, right here. Open when there's no equal, which is parentheses. Closed when there is an equal, which is a bracket. Okay. All right. Questions? Okay, number 2. G of x equals cube root of 2x minus 5. All right. Cube root of 2x minus 5. Okay. Do I do the same thing where I said the inside has to be greater than or equal to 0? Gabe? All right. So there is no restriction on this one. Do you agree? Because this is even or odd? Odd. So I asked earlier, can you take the cube root of a negative number?
No.
Cube root of a negative. So is there a restriction on this one? So there's no restriction. When will we say there's no restriction on a radical? When that root there is what? Odd. So third root, fifth root, seventh root, no restriction. And what does it mean if there's no restriction? All real numbers. And we can write it, but what do we have to have as part of our answer? Negative infinity to infinity. Again, you should know that these two things are the same, but this is the way I want your answer in the test. If you write it this way, you'll only get partial credit. Got it? Because it does specify right in interval notation. All right, questions? H of x equals the square root of x squared minus 5x minus 6. And I will tell you right now that this is one that kids struggle with on the test. Okay, are we ready? Is this an even root or an odd root? Even. Restriction or no restriction? What's the restriction? The inside must be greater than or equal to 0, right? There is an equal bar, yes? Because you can take the square root of 0. All right, here is where kids mess up. They factor, which is correct, and they say x and x. Is it 1 and 6 or 2 and 3?
1 and 6.
I want the signs to be different.
1 and 6.
1 and 6, which one's positive, which one's negative? Does that multiply to negative 6 and add up to negative 5? All right, and then they do this. If you write it down, no, I'm going to be crossing this out. And then they solve each one, and they get it wrong. They say, oh, x is greater than or equal to negative 1, x is greater than or equal to 6, and then it is wrong. All right. Do not. Is it tempting to do that?
Yeah.
I mean, if I didn't say it was wrong, would you think, oh, yeah, she's doing it the right way? Yeah, you would have listened and been like, oh, yeah, that makes sense. It's wrong. And here's why. Whenever you have a degree that's 2 or higher, to the second power, to the third power, to the fourth power, when you have that combination with an inequality, it is going to be a test value problem. Always. Test values are the last ones that we did last week on Friday. All right, so what's the two combinations? A degree 2 or higher, and an inequality. Now, if this was an equal sign, I wouldn't have to worry about test values. If that was not squared, I wouldn't have to worry about test values. But you put the two together, an inequality with a degree of 2 or bigger, and it's going to be a test value problem. Okay, so if you remember the steps that we had, first step was what? Find the zeros. All right, now when I find the zeros, I set it equal to 0. So please remember that, because I often have kids that they know they're looking for zeros, but they still put the inequality in. And then when they put the inequality in, they make this mistake that I just showed you. So do not put the inequality in when you're looking for zeros. All right, so we still factor x, what was it, plus 1 and x minus 6. All right, and now if it's equal to 0, what are my two zeros? X equals what? -1, what's my other solution? 6. All right, you're not done. Remember, we have to do test values. So make your number line. -1, 6. And what do we have? Now, open or close? We look back at the original. Open or closed? Closed. Okay. Do you guys remember how to do test values? All right, we pick a number in each section. So give me a number to the left of -1, -2. Give me a number in between, somewhere in between -1 and 6.
0.
I like using 0 when I can. Give me a number to the right of 6. 7. I plug it into the factored form. That's right here for me. I plug it in where I got it equal to 0 and factored. And I lied, that's not it for me. Where is my factored form? Right here. I plug it in right here, the factored form. All right, now this is where I decide whether it's positive or negative. Okay, so let's plug it in. -2 right here, -1, I'm sorry, +1. -2 plus 1 is positive or negative? Negative. -2 minus 6, positive or negative? I don't care how much positive or how much negative, just positive or negative. And two negatives make a? All right, next one. Where's 0? 0, I'm plugging in right here again. 0 plus 1? Positive. 0 minus 6? And a positive times a negative. And then last one, 7. 7 plus 1? 7 minus 6? Two positives make a positive. All right, now kids, I know when I did this last week asked, how do you know where to shade? We look at where it, in this case, it's at the beginning. But if you had to move anything around, you look there. Once it's equal to 0 and you have your inequality, what does this say? Greater than equal to 0 or less than equal to? And greater than equal to means positive or negative values? Positive. So I'm looking down here for my positive solutions. Is that inside or outside? Yep.
So is this like an or statement?
Yes, so it will be an or statement. So what do we, a union. It's going to be a union problem. All right, so how do I write this? Negative infinity to -1, parentheses on the negative infinity, and what do I put on the -1? A bracket. Union 6, parentheses or bracket, comma what? Infinity. Questions? Yes? What? Say it again? Why did I put a positive and a negative? Because I plugged it in right here. 0 plus 1 is a positive number, and 0 minus 6 is a negative number. I don't care how positive or how negative, just positive or negative. Good question. Anyone else? Yes?
For the infinities, will they always be parentheses?
Yes. Yes. All right. Any other questions?